This talk is about quantum particles. It's specifically about why quantum particles don't collapse in on themselves. And indeed, why they're quantized at all, and what quantization really is. Not that quantization is, but what quantization is, why things are fundamentally quantized. Well, if we take an electron and we look inside an electron, and for this you need to have a theory which allows you to look inside an electron. So I'm going to think within my theory of nature, which posits that an electron is a confined quantum wave, like a photon, like light going round and round in a little light vortex. Now, why would such a system not collapse? Well, the reason it doesn't collapse is because of quantum interference. If you take light, make it go round and round in circles, and then take it down to the ultimate smallest thing that you can do with that light, which is namely it going round in a circle in a single wavelength. So it's just one wave long. Now, the simplest reason that it doesn't collapse is because you can't get a wave which is smaller than a wavelength. It can't get smaller than that. And that's a sort of, like a rule, like it can't. But actually, it's even more fundamental than that. Why is it so strong? Why is it such a strong little thing? Well, the thing is that if you start trying to go from one wavelength down to a bit less than one wavelength, then you're going to end up in having interfering waves within that system. And those interfering waves are going to interfere, not in the quantum system itself has got itself into a state where it is perfectly smooth, perfectly harmonic, self-recreating. Try and make the thing smaller than that. You're going to have the wave beginning to interfere with itself. It's going to stack up on top of itself. Instead of being a smooth thing which comes back to its starting point and then recreates itself in a unitary way, you're going to start stacking those waves up on top of one another. They're going to interfere with one another. And what that's going to do for you is it's going to introduce extra energy. And it's not going to introduce a little bit of extra energy. This is the extra energy force which is responsible for the Pauli exclusion principle physically. And it's the physical nature of that Pauli exclusion principle which is the thing which is stopping those particles from collapsing in on themselves, electrons, but also stopping the lowest orbital in the hydrogen atom, the electron sitting there, not radiating. It's again a single wavelength electron, different size, 10 to the minus 10 meters, different wavelength because we're talking about the de Broglie wavelength and not the Compton wavelength, but still a resonant, harmonic, coherent state, exactly one wavelength long. What quantization means is it means it's countable. And you can count wavelengths. And the minimum number of wavelengths you can have is one. And that's where the quantization comes from. That's why particles don't collapse. And that's the reason that you have to have a quantum mechanics of the underlying nature of the universe.